In a world where seconds can decide the fate of nations, technology stands as a silent guardian. Behind reinforced walls and layers of security, some of the most complex machines ever created are brought to life, not for destruction, but for deterrence. This is not a story of war, it is a story of precision, responsibility, and control. A modern defense missile is not a single machine, but a system of systems, where electronics, propulsion, guidance, material science, and software work in perfect harmony under extreme standards, zero tolerance for failure, redundant safety layers, and continuous human oversight. Long before any physical part enters a factory, years of digital design and simulation test performance, analyze stress and heat, and identify potential failures, all under strict ethical, legal, and governmental review. Inside the factory, materials sourced globally are logged, tracked, inspected, and verified, where even a single bolt must meet certified standards. Production takes place in highly controlled environments where temperature, humidity, vibration, and static electricity are constantly monitored, minimizing human error through automation and layered inspections. Guidance and control systems are assembled in secure clean rooms, with software developed, tested, and audited separately to ensure no single individual controls the entire system. Modular assembly brings together independently verified components, followed by extensive testing without activation, measuring behavior through data rather than force. Throughout the process, safety, ethics, and legal oversight remain paramount, with strict limits on production and continuous monitoring. Once approved, systems are securely stored and transported through controlled routes with unbroken chains of custody. Behind every defense missile are people, engineers, inspectors, technicians, and policymakers, working not to provoke conflict, but to prevent it, because the strongest defense is one that never needs to be used.
Good morning. Let's review the annual safety objectives.
How does this affect field reporting?
Great question. We'll use the new digital forms.
Weld parameters are holding steady.
Confirmed. Monitoring the heat signature. Increase power by 5%.
Stack it in the back, secure the straps. Copy that, moving to the next crate.
The east rack is spiking. Check the logs.
I'm on it, rerouting traffic. It's stabilizing, throughput is up.
Good. Monitor it.
Listen carefully, the situation is deteriorating rapidly. We must back now before it's too late. Do you understand the gravity? technology with responsibility. The future demands we balance innovation with accountability.